All right, we're good. All right. So hi everybody. I'm Shamil. So today we'll be talking about the chemistry of EVs, electric vehicles. I mean, you guys touched on it a couple minutes ago already, so you guys kind of did half our presentation, but we'll still go on forward. So intro to EVs. EVs are the next big revolution in the automotive industry. Many EVs are currently taking over the road in the US and in the world. As you see, when we drive our cars every day, you see the electric vehicles slowly coming in and taking over. And then as we just talked about a couple minutes ago, EVs are trending towards overtaking the whole automotive market and surpassing gas vehicles. In California, the sale of gas vehicles are to be halted by 2035, transitioning to manufacture fully electric vehicles. So Gavin Newsom did pass the law, according to California.gov. So by 2035, we should have sales of only electric vehicles, but who knows? Everything's up in the air. It could change. Um, Electric vehicles are deemed to be safer for the environment, but still unsure how safe it is due to electronic waste. And I'll cover that a little bit in the next couple slides. And then companies such as Tesla, Ford, and Lucid are leading the charge in production of electric vehicles. Lucid obviously just opened their headquarters in Newark, and then Tesla, we obviously see their headquarters here. Also, China and the rest of the world are developing their own electric vehicles. Like a company called NIO is up and coming. So there's going to be a big push and fight for who becomes the top dog in the EV market. And also, electric vehicles are run by batteries. Most use lithium. I know some other vehicles use nickel and acid-based batteries. And also, there are many upsides to EVs, but not without some downside as well. So I'll give you a little rundown of how EV batteries are made. Lithium, cobalt, and graphite are typical components in batteries. Many minerals used to make batteries are expected to run short on supply. Global market for graphite is expected to grow 5.3% from 2018 to 2027. And demand for graphite is expected to grow 383% over the next 30 years. And this is according to science.com and a professor from Leicester University in the UK. So essentially, supply is not expected to meet demand. So there will be a shortfall of lithium due to scarcity of cobalt as well, about 100,000 metric tons, and about a 20% gap between supply and demand by 2025. However, there are some alternative methods. Companies are trying to increase energy densities of batteries to reduce costs. Many companies are looking into lithium air batteries, which use oxygen molecules to generate energy. So there are alternative methods that companies are looking into, because if we run out of minerals and metals to make these batteries, then obviously we're trying to transition away from fossil fuels, then we need something else, to make these batteries and these cars run. Environmental impact. When we think of EVs, we don't really think that it has much of an environmental impact negatively, because we're trying to transition away from harmful emissions to our environment. When battery life comes to an end, its green benefits fade. If they end up in landfill, its cells can release toxins, including heavy metals. For example, if you cut too deep or in the wrong area of a battery, it can short circuit, combust, and release toxic fumes in the air. So it could pretty much cause fires if you don't recycle it properly. I know there's a company, I forgot the name. They're creating alternate methods to recycling and efficient ways to where these toxic fumes don't release into the air. I just forgot the name of the company. I was looking at it earlier. Maybe I could circle back to that later. EV batteries are not meant to be recycled. There are many alternative methods that can used to extract and recycle certain materials such as graphite, but many of the methods cost too much or are extremely tedious to do. I have a short video that I'll play for you guys. just highlighting some of the other harmful effects of recycling EV batteries. So.
At Verizon, we are committed to closing America's digital divide. We are
age of the internal combustion engine. The 21st century will belong to the battery. By 2040, the majority of cars sold around the world will be powered by batteries. The 20th century was the age of the internal combustion engine. The 21st century will belong to the battery. By 2040, the majority of cars sold around the world will be powered by batteries. They'll emit far fewer pollutants than gas guzzlers, but the elements used in batteries have their own challenges. Lithium is a water guzzler. If lithium prices stay low, it may not be worth the cost to mine. The industry would likely opt for the more environmentally riskier method of pumping salt water underground to extract it. And nickel is used in lithium-ion battery cathodes. It boosts energy density to let electric vehicles travel faster and farther. But it's not clear whether miners in Indonesia can even keep a steady stream of nickel coming. And cobalt presents an ethics problem. It helps keep the battery cool during charging and discharging, but they're terrible conditions for miners in Congo, the world's top producer. Some of the workers that reporters have found there are as young as 4 years old. A cleaner car might not be made more cleanly.
What's the deal with lithium-ion batteries and risk in?
All right, so that's my portion of the slides. And then Anthony and Ernesto will continue on. I'm gonna unshare and then they'll share their screen.
So I'll be talking about the wireless charging, as you can see here. Okay, so there was this like one method that I found that it's called manipulating electric fields. So what it's about is basically like two insulated metal plates that like install underground, and then like another two that are installed underneath the vehicle. So that's basically how the vehicle is going to be charged, and then how the wireless process like begins. So then there's like this oscillating electric field that happens, which basically like attracts and repels energy charges between both those two metal plates. So then like that's how like the energy gets like transferred from the metal plates that are underground to the car. And then there's like this rectify current, and this basically is like the final process where like this is the process like where alternating current like turns into like direct current. So like the vehicle needs like direct current to get fully charged, and basically like the battery just like gets charged. And I have like a short video on like what AC and DC, alternating current and direct current is basically. It's like a small section only.
Nations are setting for transitioning. Powering an electric vehicle, AC versus DC. First things first, if you want to understand how an electric car motor works, you need to know the difference between AC and DC. Electricity moves through a conductor in two ways. AC stands for alternating current. It is described as electric current, in which the electrons periodically change direction at a determined frequency, like the pendulum on a clock. DC stands for direct current. As its name suggests, the electrons flows in single direction, from positive to negative. The battery in an electric car functions using direct current. But when it comes to the main motor of the electric vehicle, which provides traction to the vehicle, this DC energy must be transformed into AC by an inverter.
So that was a quick part that I wanted to show. And let's see. I have another video which talks about a method that it's called induction, which basically like involves electromagnetic induction. And it's like something that Northway is like developing for their taxis, and it's like a different way to like charge your vehicle so that you don't need to use any like charging stations and just like make long lines to go and charge your car basically.
As electric vehicles become more and more prominent on our roads, charging capacity more and more of an issue, Norway has come up with a clever, broad view solution for its fleet of taxis called Electricity. In the future, it might take in far more vehicles too. The Nordic country has already committed to requiring all new cars sold from 2025 onwards are electric, and intends to build an entirely emission-free taxi service to assist in its lofty aims. With charging time an efficiency limiting factor for electric commercial vehicles in particular, they'll be doing this by charging the cabs wirelessly through the taxi rank they sit on as the taxis wait to be hired. This saves in several ways. No need to hunt out an available charger, no need to wait separately for a charge and to be hired, and no need to plug in or unplug when a fare arrives, all in which to save precious time in which to earn. In the industry, after all, time is money. The charging will take place through a process called induction. To facilitate the in-place charging plates are to be installed under the road where the taxis will park up, and a receiver located in each taxi. This will allow for charging at up to 75 kilowatts entirely without cables. Induction charging works through the principle of electromagnetic induction, whereby an electric charge sent through a thick coil of wire is used to generate an electric current, the force of which in turn generates an electric current in a second coil some distance away. The process does require that the device to be charged is relatively near to the coil, and so the process is sometimes called near-field charging. As it is not absolutely precise like the connection of a cable, however, this is relatively simple to set up between a taxi and a static location, so long as the positioning of the vehicle is relatively accurate, something that can be easily achieved through normal parking. Naturally, such a process would be of limited green benefit unless the electricity being supplied to the taxis was already from a green source. Electric cars can be much greener than their petrol equivalent, but only where care is taken that the electrical source is better for the environment than the petrol it's replacing. Fortunately, Norway has that covered too, with the country's ever-improving mix of hydro and wind energy, one of the greenest energy supplies in any country in the world, as well as the world's highest rate of electric vehicle ownership. At the heart of the program is a Finnish clean energy company, Fortum, through their Charge and Drive program. The company are long-time collaborators with Norway's taxi industry, with a particular focus on the ease of infrastructure, and will be heavily involved in the setup of the earliest parts of this project. Major car firms like Jaguar and Land Rover are also stepping up to the plate. The very first step is expected to be active in 2023 and will involve the installation of charging stations at the taxi rank outside the main station in capital city Oslo. The process is relatively slow, as beyond the digging up of the road for installation outside the main station, it also requires all the taxis are set up for charging. Taxis will be able to drive up to the charger and a wireless charging session will automatically start, Annika Hoffner, head of the project, said. This allows the taxis to charge in a place where they would anyway be waiting for new customers. The difference is that they won't be emitting exhaust while waiting. Instead, they will be receiving renewable energy to charge the taxi's battery. Whilst this is simply an early step, Norway is a logical place to take such a step towards a wider network. As well as its broadly green approach to energy, the Nordic country also has one of the strongest markets for electric vehicles in the world. In the long term, though, there could be far wider applications to this kind of technology. There's already research taking place into how to charge cars as they travel. while putting a charging coil in a single location or several single locations, such as in the taxi ranks, is an affordable option, doing the same down an entire street for on-the-move charging is far more challenging in terms of both cost and expanding the technology beyond a single industry. That said, Renault began looking at the idea way back in 2012, creating a route on the outskirts of Paris that enabled the ongoing charging of 2 of their Kangol electric vehicles as they drove. While the main aim is a kind of grazing charging, adding to the battery between larger charges, this could, in theory, allow indefinite driving, especially perhaps in combination with self-driving car technology. In practice, the bigger benefits are on the green energy side, as well as potentially allowing both greater ranges and smaller batteries in future electric cars. The huge infrastructure challenges do mean its everyday use is not on the immediate horizon. For now, Norway and its taxi industry might just be the perfect testing ground. The country already has the highest rate of electric vehicles in the world, and its relatively small population allows for changes like this to be made fairly quickly and unobtrusively. Also, Norway is not the home of a single automotive company likely to lobby against the changes, and so is free to put in place all kinds of benefits for switching to electric without any excessive lobbying or economic pressure. Benefits for electric car use so far have included free or discounted road tolls, parking and charging points, and a tax exemption. The number of purchased new cars that are electric is closing in on half of all new vehicles in the country, so the process is well underway. Would you like to see money invested in areas like this in your country?
Okay, so that would be like part of my the presentation. And now it's Ernest's part now.
Hey guys, I'm going to share my screen right now. Just give me 1 second. All right, guys. Thank you, Shamel and Anthony, for the information provided. My name is Ernesto, and I'm going to be talking about how electric vehicles are the future and their pros and cons. So if you don't know by now, electric transportation, and here are a few reasons why. They're more economical and low maintenance. With rising costs of fuel, there's a growing interest in electric vehicles due to their lower running costs. Electric vehicles are cheaper than their gas counterparts. Their operation cost is less than half of a gas-powered vehicle. Part of that is because electrical motors have fewer parts than fuel-based engines, which leads to less wear and tear, so they require less servicing. With no friction between and moving parts or exchanging between liquids and gases, it does not need lubricant or exhaust. In turn, means no oil changes, and eliminating the need of related services. EV owners can expect to save money over the lifetime of their vehicle compared to conventional internal combustion vehicles. Saving over their life of most EVs range from $6,000 to $10,000. Without the need of oil, EVs can lower oil import by $60 billion by 2030. Governments have started to implement incentives and regulations. The main regulatory incentive is to decrease CO2 emissions with hope of achieving a future with zero emission vehicles as the normal. It is a work in progress, and states California and New York have already signed legislations to phase out internal combustion engine vehicle sales by 2035. Biden has also called for $174 billion in government spending to boost EVs, including $100 billion in consumer incentives. Public and commercial sectors. The EV adoption in public and commercial sectors is slow going right now, and that's due to the cost of replacing the existing infrastructure. But the long-term costs, environmental and health benefits of switching to electrical vehicles is pushing both industries in that direction. As you see in that picture in the bottom right, that's the first electric fire truck in the nation, and it was welcomed by Madison Fire Department in 2021. And in the coming years, electric sanitation trucks will be quietly picking up garbage and recycling, and more electric trucks will be delivering packages from warehouse to homes, air pollution free. Electric buses are already hugely popular in China, while Europe is picking up the pace of adoption. In the UK, around 38% of the railway network is electrified. Reduced emissions and noise pollution. Around the world, governments are attempting to reduce the emissions and boost air quality through electrical vehicles. According to the Environmental Protection Agency, one gas-powered car rated at 22 miles per hour emits an average of 4.6 metric tons of carbon dioxide per year. While EVs have zero tailpipe emissions, they also have more quiet motors than gas-powered motors, which drastically reduces noise pollution in urban areas. Energy efficiency. EVs are more efficient than gas-powered vehicles. Due to the laws of thermodynamics, gasoline engines offer efficiencies ratings of only about 15%. This means that most of the energy generated during combustion is lost to the environment. Electric cars can offer efficiencies around 70% depending on the vehicle and driving speed. These are just a few reasons to why EVs are the future. As great as they sound, they also come with a downside. Starting with this. So I'll just start the slide over. The downside is, starting with disappointing battery capacities. An average charge gives you about 200 miles, making the EVs perfect for city commuters, but can be limited for long trips. And if you're making those long trips, you have to consider the charging times because it takes a lot longer than it does to pump gas. Normal charging, depending on the voltage, 11 hours, while a fast charger can take about an hour. Either way, you'll still have to wait. But if you choose to always fast charge, you're risking reducing the lifespan of the battery, resulting in battery replacement. Over time, the battery will be less efficient and will hold less charge. Industry stats predict that most electric car batteries will last between 10 and 20 years before they need replacing. But most automakers change it.
Okay, so we already saw this slide. So can we go to the next slide? Yeah, good. Okay, can you show the next slide?
The last one.
Oh, this was the last one?
Yeah.
Okay,